cosmic enigma defies odds and logic. China's Mars orbiter captures a rare glimpse of Three-Eye Atlas.
On November 5th, the Virtual Telescope Project released 2 new images of the interstellar object known as Three-Eye Atlas. What they revealed has left the scientific community more baffled than ever. The images show Atlas as a compact, star-like point of light with no obvious cometary tail. Even more surprising, its appearance has barely changed since the Hubble Space Telescope's observations back in July 2025. For an object that should have lost a tremendous amount of mass, the absence of a large glowing coma is, quite simply, inexplicable. To put this in perspective, similar images have captured a common solar system comet, Comet Lemon. Lemon shows exactly what we'd expect, a bright, transparent tail pointing away from the sun, formed by solar radiation pressure pushing gas and dust into space. Atlas, on the other hand, remains mysteriously clean. It shows none of the visual signs that should accompany the massive loss of material required to account for its strange motion. According to Harvard astrophysicist Avi Loeb, this is the latest evidence that Atlas is unlike any natural object we've ever seen. And this leads us to a fundamental question that science needs to take seriously. There has been a lot of confusion about Atlas and its acceleration, so let's analyze the actual data. On October 29th, as it approached its closest point to the Sun, this celestial body suddenly accelerated in a way that defies normal gravitational laws. A report from NASA's Jet Propulsion Laboratory, JPL, confirmed that Atlas's actual position had deviated from its predicted orbit by 4 arcseconds, a number that seems small, but at a distance of 203 million kilometers from the Sun, this represents a massive error, one that stunned scientists. Atlas is accelerating at a rate of 0.2 millimeters per square second. To put that in perspective, this is equivalent to being pushed off its expected course by more than 80 kilometers in just 1 month. The data shows this acceleration is happening in 2 distinct directions: an outward push away from the Sun at a rate of 135 kilometers per square day, about 60 kilometers per month, and a sideways push at 60 kilometers per square day, about 270 kilometers per month. In other words, Atlas is drifting in 2 directions at once, being pushed both out and sideways. Before this raised public concerns, NASA was quick to insist that Atlas is not hurtling toward Earth. Its lopsided orbit poses no threat to any planet, though it could make a close approach to Jupiter in March 2026, a date astronomers are watching closely. But what is actually accelerating Atlas? Imagine you throw a ball and gravity pulls it along a perfectly predictable curve. But if some invisible force were firing tiny rockets at it, that trajectory would change. That's exactly what's happening here. Atlas is no longer obeying the rules of pure gravity. Something else is acting on it. With comets, the most likely explanation is outgassing, when surface ice melts from solar heat, turns to steam, and is expelled like a natural jet engine. But what has researchers completely stumped is the sheer scale. The amount of gas required to create Atlas's observed acceleration is absurdly large, far beyond what any normal comet could possibly release. Could something else, an unknown natural mechanism, or even a more mysterious artificial factor, be manipulating Atlas's motion? This remains the core mystery, one that has sparked dramatic theories across the scientific community. This is where things get truly staggering. Harvard astronomer Avi Loeb has performed fundamental physics calculations, showing that if you know an object's acceleration and mass, you can deduce the thrust needed to cause it. Atlas weighs at least 33 billion tons, making it far larger than the first two interstellar visitors, Oumuamua and Borisov. Its core is estimated to be about 3 centarcs, or nearly 6 kilometers wide. Given that immense mass and its observed acceleration, the calculations lead to a remarkable conclusion. To generate this thrust through natural outgassing, Atlas would have to lose at least a sixth of its total mass during the month around its closest point to the Sun. That translates to the expulsion of at least 5 billion tons of gas. And yet, the latest images reveal nothing. No grand tail, no obvious cloud of debris, just a silent, compact object defying explanation as it journeys through our solar system.